Okay, so we're still focusing on our U substitution process here. Again, there's not really a good alternative to integrating in this case. The most that we could do is we could rewrite, so we have 1 over 10x minus 3 dx. We could write it as 10x minus 3 to the negative 1. But again, it doesn't really help us because when we use that general power rule and we add 1 and then divide by negative 1 plus 1, do you see that both of those are 0, right? So we would have something to the 0 divided by 0. It doesn't help, right? It's kind of the one exception to that general power rule. So this is where our natural logarithm rule comes in. It's actually a really, really useful rule that you're going to see quite a bit of as you move forward through your other math classes, or your other calculus classes, I suppose. So the rule here says we still use U substitution. So you would say let U be equal to, I'm going to take my denominator here as my U substitution, or my U. So 10x minus 3. Again, I don't want to take the whole thing because my derivative, du, is not going to be there, right? It needs to be there. This derivative is 10 dx, or just how we write du is 10 dx. And then I'm going to divide so that we have du over 10 takes the place of dx. So we make that substitution, we have 1 over u, and then this is going to be du over 10, which I'll move 1/10 out front. I am okay if you just move the 1/10 out right away. Again, just make sure you understand it as these get more complicated next semester and you do things like integration by parts, and those are other processes. You just want to be careful more than anything, right? Because one little tiny thing can throw the whole answer off. According to our theorem, the 1/10 is a scalar multiple, so it just carries out front. But this is times, and we get ln absolute u plus c. And we can substitute that back in, so we have 1/10 ln absolute 10x minus 3 plus c. If you really want, you can rewrite, because that 1/10 can become an exponent. I'm not even going to write it because I don't really think that's necessary. This is more than sufficient as an answer.